Here we have a cold glass of water. Temperature is T0. Ambient temperature of the room is R, and T is the temperature of the water. And each minute, the temperature of the water will increase by this much. So if it starts off as T0, after 1 minute, the temperature will be 2%. It'll be T0. It's going to increase from what it starts at, T0 plus 2%, 0.02 of R minus T, which in this case is the temperature it is now. We leave it at T0 for a second. So that's going to be equal to T0 plus 0.02 R minus 0.02 T0. So it's going to give me 0.98 of the original temperature plus 0.02 of the room temperature, which makes sense. So that's after T1. We might have to write a few of these out. Let's look at T2. It's equal to, based on what we started with, it's going to be 0.98 of T1 plus 0.02 R. So T2 will become 0.98 times this whole expression here. So times 0.98 T0 and 0.98 times 0.02 R. That's 0.98 by T1, don't forget this one, plus 0.02 R. What about T3 is equal to 0.98 based on this one, T2 plus 0.02 R. So T3 becomes 0.98 by all of these guys in T2. So we have 0.98 by 0.98, so it's going to be 0.98 cubed by T0 plus 0.98 by this one, 0.98 squared by 0.02 R plus 0.98 by this guy, and then plus the other 0.02 R. So we have it in terms of T0, and if we reverse this guy around, factor out the R, we get R times 0.02 plus 0.02 by 0.98 and so on, all the way to the last term in our sequence, which is 0.02 by 0.98 squared. So this is an n minus 1, but we have a geometric progression here. A is 0.02, or the common ratio is 0.98. So Sn of this, A times 1 minus R to the power of n over 1 minus R becomes 0.02. R is going to be multiplied by all of this, so I'll stick it in here. R times 0.02 times 1 minus R 0.02 to the power of n over 1. Sorry, my R is 0.98, 0.98 is reading it over 1 minus 0.98. Well, that's 0.02. So those two will cancel, and then we just have R times the bracket, R times 1 minus R times 0.98 to the power of n. And then bring down what we originally have in terms of T0. We have 0.98 cubed, so it's the power of n times T0. Then we're going to have plus this R, and then minus the other one. So this is Tn. Just tidy it up a little bit. Tn will be equal to R. And then I have plus 0.98 to the power of n as common factors. leaving T or T0 minus R. Okay, that's what we look like we have for Tn. Let's see what's next. We're asked to find, do some other information too. So glass of the temperature of the water, 8, room temperature 22, 8 for R and 22 for T. So around 8 for T and 22 for R. So just filling this in, T10 is going to be 22 plus 0.98 times 8. It's going to be, change the temperature, it's going to be 8 minus 14. T10 on a calculator works out to be 10.56. I'll just do T60, simplifying on the calculator the same way. T60 works out to be 17.834, and T100 on a calculator works out to be 20.143. 3 answers here. After how many minutes to the nearest minute will the water temperature be greater than 21? We're getting close to it. So we're looking for N here. So when will R 22 plus 0.98 by T minus R, which is the 8 minus 14. When will this be greater than 21? Left it way in there. So we're going to have, so I'm thinking the answer here, it's 8 minus 22. So if I bring the 21 to the left, we're going to get 22 minus 21. And bringing the minus 14 to the right, this minus 14 will make it positive. We'll have 14 times 0.98 to the power of n. So this will be 1 on the left, divide by the 14. And I get the log of both sides. Actually, I should probably reverse it around first. It doesn't matter though, I can change it around. So the log of this greater than on the right hand side with 0.98 by the log n times 0.98. So it'll be the log of n log 0.98. So dividing the log of 1 over 14 divided by the log of 0.98. We get that. N has to be equal to, well, my calculator's giving me 130.62. So 131 for N. And for the last part to show that it tends towards 22, we show that this guy, as N increases, tends to 0. So that's why it's kind of tending towards 22 degrees.